Assalamualaikum and a very good morning to everyone. My name is Nisa Naima binti Khalid. I am master student from Faculty of Engineering and Built Environment at University Kebangsaan Malaysia. Today, I'm here to present you about a review on bonding of polyamide reinforced carbon fiber via additive manufacturing. Before we start to know about my paper, firstly, we will look about the additive manufacturing. Next, we will know about its advantage of using this material, and then the aim of this paper, and finally we will discuss what this paper outcome. In introduction, an additive manufacturing, also known as 3D printing, rapid prototyping or preform fabrication, which is the process of joining material to make object from 3D model data, usually layer upon layer or layer by layer, as opposed to subtractive manufacturing methodologies such as machining. In additive manufacturing, it has shown a few advantages in this method, which is this method has shown it has a rapid prototyping, cost-effective, flexibility, tangible, design, good quality part, consistent quality of the part produced, more accessible and sustainable. Their limitation is obvious layer by layer effects as the material being printed, which can be minimized through the minimizing its necking behavior during the interlayer fusion bonding process. Being printed by the 3D printed have minimized their necking behavior during the interlayer fusion bonding process. In my paper, I have used a carbon fiber strengthened polymer composite, which is polyamide, in a 3D printed process. 3D printed of carbon fiber strengthened polymer composite have shown a few advantages in current application, which in metal, it gives a lightweight, high strength and stiffness, and they offer to resist corrosion and fatigue. CFRP, which is carbon fibers reinforced polyamide, have a potential in aviation application, which it includes a lightweight, high strength and stiffness, which I have told before. In addition, 3D printing makes it feasible to finish the elements which have been created by CAM software-based CAD model. The 3D printing have used a CAD model to make it a rapid prototyping in manufacturing. In a recent study, it has attracted the research attention when the 3D printing as it exponentially evolved manufacturing technology covering a process of joining material to make objects from 3D model data, usually layer by layer, give a numerous advantage. Firstly, I would like to describe the problem statement in this paper, which is a major factor that will limit the performance of PACF in 3D printing is interlayer delamination and is exacerbated owing to the introduction of continuous fiber in this process. The main objective in this paper is to review on interlayer bonding of polyamide reinforced carbon fiber by using 3D printing method on their mechanical properties. So, this paper has aimed to review the interlayer bonding of PACF using 3D printing method on their mechanical properties, which is tensile test. I have chosen a polyamide composite filler as my review paper, which polyamide has introduced amorphous polymer to prevent severe warpage so that it could be applied to FDM technologies. In addition, continuous carbon fiber also showed when a continuous carbon fiber reinforced polyamide was chosen in this study due to their superior mechanical properties. In previous study found, continuous carbon fiber too were found in continuous carbon fiber reinforced polyamide, which is CFRP, contain of 48 what percentage of pure continuous carbon fiber. This material have used parameter which can give good properties in end part, which the parameter used temperature of fiber and metric nozzle was 217 degrees Celsius, printing speed was 15.8 mm per second, and the average of CCF width was 1.2 mm. 3D printing have used a CAD software to design a compaction in PACF. So the process was started with the 3D model CAD Design, and then it converted into the STL file, and then the file has sliced the model, then the FDM process, and then end part. The design compaction of PACF using CAD software has used some parameter and then their value which I have included in this slide, which is printing speed is 13 mm per second, infill density 100%, nozzle diameter 0.4 mm, printing raster angle which include of 0 degree, 45 degree and 19 degree raster angle, layer thickness of 0.15 mm, nozzle temperature is 216 degrees Celsius, environment temperature 22 degrees Celsius, buoy plate temperature which is 13 degrees Celsius, 55 degrees Celsius, 80 degrees Celsius and 105 degrees Celsius. This is the image on the FDM manufacturing process in A, and the part which have the raster angle at the end of the FDM process, or we can also call as 3D printed, which is degree architecture, 45 architecture, and lastly, actually this is 19 degree architecture, but in 19 degree, it has include of 0, 45 and 19 degree in architecture. The characterized, firstly, we have tensile test. Tensile test has planned to use in GOTAC testing at speed of 2 mm per minute. The design test have followed ISO 527-5, which the specimen dimension of 215 times 15 times 1 mm, which their length, width, and thickness of the sample dimension. Tensile test has summarized as less material agglomerate were observed due to the tendency of fiber flow rate fluctuation, and carbon fiber is well infiltrated in PAC metric. Second, fiber tend to distribute to the orientation which may influence the tensile properties. Tensile strength of fiber reinforced thermoplastic is also connected to the distribution of fiber orientation. Distribution of fiber orientation we can see in previous slide, and then the parallel to the deposition direction, fiber can bear more loading, achieving higher tensile strength. The parallel to the deposition direction we can see in 0 degree angle. Lastly, printing direction along 19 degree. Although fiber oriented along printed direction, they are perpendicular with tensile loading direction which fail in carrying a load and thus result decreased tensile property. So, conclusion that have been made, it has shown the printing parameter has affect their mechanical properties in the process. In orientation, continuous fiber with zero angle could effectively improve the bear loading capability of composite. Besides, 0-degree angle have a higher tensile strength according to the tensile property parallel to the deposition direction when compared to the 45-degree angle and 19-degree angle. The flexural strength at zero angle has shown have a higher energy absorption. To conclude, zero angle have higher mechanical properties among the other rested angle, which is 45 degree and 19 degree. Thank you.